Hey, good morning, everyone. Don Gillis from Emerson Educational Services. It's been a while since I spoke with you. I think the last time we talked about check valves and discharge ports of the compressors and what have you to prevent that re-expansion gas or jeopardize that volumetric efficiency back into our scrolls and what have you. Today, I want to talk about two safety devices specifically. I had the opportunity to work down in the Lebanon, Missouri plant recently. I worked on the assembly line for a week or so and got to see a lot of this thing installed. Actually was working in a rotation of 4 different positions. Really enjoyed it. Anyways, I want to talk about something we talk about in our classes all the time that you may or may not be aware of. And the two safety devices I want to talk about today are going to be the IPR and the TOD. The IPR, notice this is what we're going to call this is what we call the muffler plate, and I'll show you this in a diagram I'll pull up here in a little bit, okay? This literally sets, the top cap sets on here. Once the gas comes through the muffler plate, okay, this is going to be your high discharge gas on the top of this side. Anything below that, your scroll set and what have you, is going to be your suction gas behind that, okay? So you can see on both sides, there's a hole here that leads to that TOD, thermal operating disk. It's a bimetal disk that's going to go off on temperature. You'll notice if you put TOD in our application AE bulletin apps, let me pull that up. Sorry about that. AE apps, bulletins, okay. If you put TOD in there, you're going to see different temperatures, but one thing for sure is you're always going to see everything going off temperature wise, somewhere between 260 to 290, always right below that 300 mark where we start to lose our lubricity with our oil. Okay, that's something I've learned quite fast here at Emerson from reading so many A bulletins when I first got here. The other thing we're going to see here is an IPR. Okay, now once we get into higher tonnages, we're not going to see these devices in there. You're going to see devices from the OEM on the discharge lines for pressures and what have you. You may have to put some kind of high pressure control leaving the compressor there, and we'll get into that for another day though. But specifically today, I want to talk about the IPR. The IPR is based on pressure. The TOD is based on temperature. Again, that TOD is a bimetal that's going to react on temperature, separate between the two metals, okay, go off. They are both going to shoot gas down on the inherent protector that's in the windings, which goes off on high amp or high temperatures, okay? Now, again, the TOD somewhere between 260, 290, depending on the application. I'm talking about refrigerants and what have you. The IPR, on the other hand, on all refrigerants with the exception of 410A is going to be somewhere between 375 and 450, okay? And that's a pressure, the IPR is a differential between the high side and the low side. This muffler plate separates the discharge gas from the suction gas, okay? Once it goes through that hole, okay, through the scroll set and up through that discharge port in the scroll set, it's then going to be right here. And that top cap sets of the scroll sits right on top of there. This was actually one of my jobs at the Missouri Lebanon plant recently, about a month or so ago. I was putting the top caps and the muffler plates. And here's the top cap. Here's a perfect example of the top cap back here on my little kit. And here is this is an actual assembled one that we've cut open. Here's that IPR and that TOD. See the ports on this side? So when this gets too hot on the top side of that muffler plate, it's then going to open up either one of them, okay? Whether it's by pressure, and again, that IPR is pressure differential between the high side and the low side, all right? When it's 410A, we're looking more like in the 625 area, somewhere like 575 to 625. On the other refrigerants, it's going to be somewhere between 375 and 450, depending on what A bulletin you pull up, okay? But somewhere thereabouts. Again, muffler plate separates the high side from the low side. Everything above that muffler plate, below the top cap, is going to be your discharge gas. Here's your discharge port. You can see inside there also. There's our check valve for that one there. It's kind of hard to see, but you can see that there. So that's that. Let me pull up something here for you. share my screen for just a minute. Okay. See what this looks like. Okay. Now, if you don't know this, we have a bleed port in here on the top of the scroll set. We've got a 2-pole motor. We're running around 3,500 RPMs. Okay. We start unloaded. Okay. That's how we get away with having a 2-pole motor. As it starts to pull gas in through the scroll set, when the contactor pulls in, we have a little bleed port right in the medium area of that scroll set. So we got low, medium, high, and then our discharge port. Okay. Here is that muffler plate I was telling you about, discharge gas. This is just a little deflector that's installed in the top, in that top cap there. This one doesn't have it, but this again was cut open, assembled for us, but comes through there. What this bleed port does is this floating seal is also a safety device, but it also helps on startup. What it is, this bleed port fills that cavity there full of pressure, pressurizes that cavity. If you notice these ledges here, that floating seal is actually sitting down on that ledge. So within seconds, and I mean right away, this will fill up. This scroll starts to move, pressurizing the gas, this medium area, pressurizes this cavity, pushing this floating seal up against the bottom of that muffler plate, okay, which then in turn doesn't allow that discharge gas to go back into the suction area, okay, below the muffler plate. Once that butts up against there, this is like a donut. I've showed you floating seals before. This is just a half of a picture. The scroll was cut in half for you, put up there. Now, the reason that we consider a floating seal a safety device, if for some reason that compression ratio, which we've talked a lot about, gets higher than it's supposed to be, on the low side to the high side, okay, the high compression ratio from the discharge gas to the suction gas, that ratio, this pressure will get weaker and weaker inside this medium cavity here of the scroll set, and it won't have enough pressure to hold up that floating seal, and it'll drop, okay? So the floating seal is also a safety device. Keep that in mind. Oops. There's a TOD right there. That's the bottom of the floating seal looking at it. Okay. Here's our IPR right there. You can see the IPR. Okay. High pressure side. Above that is again the muffler plate. Everything is high pressure gas. Below that is low suction gas. Okay. Here is our check valve in the discharge port on this. Prevents discharge pressure from flowing back into the compressor during shutdown, helps reduce shutdown noise, volumetric efficiency. I could go on and on and on. Okay. See. That's all I wanted to talk about there. I also wanted to bring up one more thing here. Wanted to bring up some information that was recently shared with me, at least this form was. And we have to remember about our thermistors. Our thermistors inside the compressor, okay? We have 4 thermistors inside the compressors connected to the windings. This just shows you a diagram from 20 to 40 ton Copeland scrolls. The thermistors wirings is showing the models over here, what they're connected to. Here we have the Core Sense, another Core Sense, and then we have the Coron product. Okay, and down here again, another Coron module there. You're also going to have one thermistor in the discharge port itself. Okay. So I want to make you aware of those. And you can test these thermistors, ohm out through the control protection module, whether that be Corsense or the Chromon. Again, you can find a lot of this stuff on your AE bulletins, your app. Don't forget the app. Bring it up to you one more time. If you're not familiar, you can email me. Okay. Our AE bulletin app. All right. Stop sharing that. And I think I ran over, I know, but I think that at least gets my feet wet and back in front of you to start this video thing again. I will be traveling a lot, or we will be traveling a lot coming up in September or so, or the end of August, mid-August, somewhere thereabouts. But I wanted to get a couple of these made and get them out to you. Hey, if you're in the States this weekend, happy 4th of July weekend. Be safe out there. Everyone on call, as always, lock out, tag out. Okay, if you're not sure what that is, send me an email, don.gillis@emerson.com. Feel free to ask me any questions. If I can't answer them, I'll get you an answer. Be safe out there if you're on call. Always, always, always be safe. Look out after another and one another, and share the knowledge as always. To everyone that's doing podcasts out there and all the things you're doing online, I know I haven't been real connected out there lately because of so many things going on behind the scenes, but good stuff, great stuff. I don't want to start naming names because as soon as I do that, I'll forget someone out there, and I don't want to hurt anybody's feelings. But anyways, good talking to you again. I'm Don Gillis from Emerson Educational Services. Don't forget to check us out at education.emerson.com. The classes are filling up really quick. Like I said, the last I looked, I know that me personally, I'm booked until the first of the year, and then they're already starting to fill the classes in from January to May. And I saw some classes already being scheduled for fall of 2022. So if you're interested, take a look at that. If you want some instructor-led training, and if you have any questions, concerns, or something you'd like to see or hear more of, shoot me a line. You can reach out to me through LinkedIn or my Facebook page at Fun Facts, where I'll post this, and on the LinkedIn page. And again, my email is don.gillis, GILLIS, @emerson.com. Be safe, everyone, and take care of each other. Okay. Bye. Thanks a lot. Bye.